Voltage induction can occur in electrical wiring systems. Several factors contribute to this phenomenon, and it's important to understand these to troubleshoot effectively. Firstly, crosstalk between conductors can cause voltage induction. In 14.3 non-metallic sheath cable, there are three conductors, the hot, neutral, and ground, running parallel to each other. When current flows through the hot conductor, it can induce a voltage in the adjacent neutral and ground conductors. Secondly, proximity to other electrical cables is another factor. Parallel electrical cables carrying current can also induce a voltage in nearby cables. This is especially common in areas where multiple cables are bundled together. The position of a switch also plays a role. When a switch is in the off position, it breaks the circuit, but it may not completely isolate the outlet from the electrical system. In some cases, stray voltage can still flow through the switch terminals and into the outlet. When measuring voltage, consider the type of meter used. Digital meters are more sensitive to stray voltage than analog meters. This means they may display a non-zero voltage even when there is no true voltage present. Also, capacitance can affect voltage measurements. Electrical devices, such as capacitors, can store energy and discharge it slowly, creating a small voltage. This can be detected by sensitive meters even when the device is turned off. To troubleshoot voltage induction, follow these steps. 1. Check the load. Disconnect the load from the outlet and measure the voltage again. If the voltage drops to zero, the issue may be with the load itself. 2. Reposition cables. Separate the 14.3 non-metallic sheath cable from other electrical cables and route it in a way that minimizes crosstalk. 3. Ensure switch isolation. Turn off the switch and verify that there is no continuity between the outlet terminals. If there is continuity, the switch may be defective or improperly installed. 4. Use a true root mean square meter. True root mean square meters are more accurate than non-root mean square meters when measuring distorted waveforms that may result from induction. The use of 14.3 non-metallic sheath cable can contribute to voltage induction, but it is not the only factor. The proximity to other electrical cables, switch position, and meter type can also influence the voltage measurement. By following the troubleshooting steps, you can identify the cause and take appropriate corrective action. When dealing with electrical systems and voltage induction, several additional points are worth considering for a comprehensive understanding. These include grounding and bonding, shielding, cable length, load characteristics, electromagnetic interference, and easy code compliance, insulation quality, the impact of harmonics, surge protection, and regular inspections. Proper grounding and bonding are critical in mitigating voltage induction. A well-grounded system provides a low impedance path for stray currents, reducing the potential for voltage buildup. Bonding, which connects non-current carrying metal parts, helps ensure that all components are at the same potential, further minimizing induction effects. Shielding involves using conductive materials to surround cables or equipment, preventing electromagnetic fields from inducing voltages in nearby conductors. Shielded cables, such as those with a metallic braid or foil, are particularly effective in environments with high electromagnetic interference. Cable length can also influence voltage induction. Longer cable runs are more susceptible to induction because they provide a greater surface area for electromagnetic fields to interact with the conductors. Keeping cable lengths as short as possible can help reduce induction effects. The characteristics of the electrical load connected to a circuit can affect voltage induction. Nonlinear loads, such as those found in electronic devices, can generate harmonics that increase the likelihood of induction. Using appropriate filters or power conditioning equipment can help mitigate these effects. Electromagnetic interference, or MA, from external sources can also induce voltages in electrical wiring. Sources of electromagnetic interference include radio transmitters, industrial equipment, and even natural phenomena like lightning. Shielding, filtering, and proper grounding can help minimize the impact of EMI. Compliance with the National Electrical Code, or NEC, is essential for ensuring the safety and reliability of electrical systems. The NEC provides guidelines for wiring methods, grounding, bonding, and other aspects of electrical installations that can help minimize voltage induction. Referring to specific articles and tables within the NEC, such as those related to grounding and bonding requirements, can provide detailed guidance. The quality of insulation on electrical conductors can affect voltage induction. Damaged or deteriorated insulation can increase the leakage current between conductors, leading to higher levels of induction. Regular inspection and maintenance can help identify and address insulation issues. Harmonics, which are multiples of the fundamental frequency of the electrical supply, can exacerbate voltage induction. Harmonic currents can flow through neutral conductors and induce voltages in nearby wiring. Using harmonic filters or power conditioning equipment can help reduce the impact of harmonics. Surge protection devices, or SPDs, can help protect electrical equipment from voltage surges caused by lightning or other transient events. While surge protection is primarily intended to protect against overvoltages, it can also help minimize the impact of voltage induction by clamping transient voltages. Regular inspections of electrical systems can help identify potential issues related to voltage induction. Inspection should include checking for loose connections, damaged insulation, and other signs of wear and tear. Addressing these issues promptly can help prevent more serious problems from developing. Understanding these additional factors and implementing appropriate mitigation measures can help ensure the safe and reliable operation of electrical systems in the presence of voltage induction. Considering specific scenarios and examples can further illustrate the principles of voltage induction. For instance, in a commercial building with a large number of fluorescent lights, the cumulative effect of electromagnetic interference from the ballast can induce voltages in nearby control wiring. In this case, using shielded control cables and ensuring proper grounding can help minimize the effects of induction. In an industrial setting with heavy machinery, the electromagnetic fields generated by the equipment can induce voltages in nearby power cables. Using shielded power cables, separating power and control wiring, and implementing a comprehensive grounding and bonding system can help mitigate induction effects. In a residential setting, the proximity of electrical wiring to electronic devices, such as computers and televisions, can induce voltages in the wiring. Using surge protectors, ensuring proper grounding, and keeping wiring runs as short as possible can help minimize induction. When troubleshooting voltage induction issues, it can be helpful to use a systematic approach. This might involve measuring voltages at various points in the circuit, checking for continuity between conductors, and inspecting wiring for damage or defects. Using a true root mean square meter can provide more accurate voltage readings, especially when dealing with distorted waveforms. In addition to the troubleshooting steps previously mentioned, consider these advanced techniques. Firstly, use a clamp meter to measure current flow in the conductors. Excessive current in one conductor can induce voltage in nearby conductors. Secondly, perform an insulation resistance test, also known as a mega test, to check the integrity of the wire insulation. Thirdly, use an oscilloscope to visualize the voltage waveform and identify any distortions or anomalies caused by induction. Fourthly, analyze the circuit layout to identify potential sources of induction, such as parallel runs of lawn cables or proximity to high current equipment. Fifthly, consult with a qualified electrician or electrical engineer for assistance in complex cases or when safety is a concern. Staying up to date with the latest advancements in electrical technology and best practices can help ensure that electrical systems are designed, installed, and maintained in a way that minimizes voltage induction. This includes participating in continuing education courses, attending industry conferences, and reading relevant publications and standards. Remember that electrical work can be dangerous, and it is essential to take appropriate safety precautions when working with electrical systems. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following lockout/tagout procedures to de-energize circuits before working on them. When in doubt, consult with a qualified electrician or electrical engineer.